Okay, so here is our second example for this topic. So we have two similar shapes, bigger four-sided object and a smaller four-sided objects. For them to be similar, what that tells us is if we take like each length has like a matching length. It's just either scaled down or up. So for example, this 6.7 corresponds to this length of the smaller shape. This 8.2 corresponds to this length of the bigger shape. I say this 8.2 over here correspond to this length, but since they're both 8.2, I know they're both going to be identical. So I'm going to label these ones A and that one B. So basically I'm trying to find what is A and B of these corresponding shapes. So now, but for us to approach this one, we first have to find the K factor. So what we can see is that we know that this small length is 3 for the big one, and this small length is 2 for the smaller object. So we can look at those two numbers to determine our K factor. Now we're not really told which is the bigger or which is the original object. So it doesn't really matter which one you decide that you want to be on the top for the equation. Because remember on the equation we said K is equal to the diagram over the actual, right? It doesn't really matter. We find one or the other. So what I mean by that is if I take this 3.0, I'll put this on top, 3.0 centimeters, and I'm going to divide it by the corresponding 2.0 centimeters. You take your calculator, or if you can do it in your head, that's great. We have 3 divided by 2, and that is 1.5. So that's meters, sorry, not centimeters, meters. The meters cancel out. 3 divided by 2 is 1.5. So our scale factor is 1.5. So what that means is if we're going from the small to the big, we're multiplying by 1.5. If you're going from the big to the small, we're going to divide by 1.5. Right? So to go in this direction, I'm going to multiply it by 1.5. To go in this direction, we're going to divide by 1.5. Now, if you kind of did the opposite, if you took K and you went 2.0 over 3.0, we could still solve it. If you said 2 divided by 3, that gives us 0.6 repeating. So technically, both these scale factors is correct. What it would mean, though, if the scale factor from here to the other one, if I want to go in this direction, it would be the same as saying multiplying it by 0.6 repeating. Or I can go back in this direction by dividing by 0.6 repeating. So it doesn't matter. So we can go either direction. So I can use from small to big using the 1.5, or I can multiply 1.5, or I could divide it by 0.6. It's still the same thing. Or I can go from big to small by multiplying by 0.6 repeating, or I can divide by 1.5. They end up being the same thing. However, because this 1.5 is a nice number, I'm going to go with that one. So I'm going to go ahead and erase this 0.6. Again, it still would work. You can try it out. You get the same answer. But we're going to use that 1.5 scale factor. So what we're going to do is we say, okay, we have this 6.7. And I said, okay, if I divide this 6.7 by 1.5, it will get me B. So I go, if you want to write out as the equation, we have K is equal to, we have 6.7 over B, and that's equal to 1.5. Because basically what we're saying is each corresponding length has that same scale factor. So if we want to solve for B, what we're going to do is we're going to multiply both sides by B. So we end up with 6.7 is equal to 1.5 times B. And then we're going to divide both sides by 1.5. So you get your calculator out, 6.7 divided by 1.5. You get a length of B is equal to 4.5. I'm just going to round it. It comes out to be 4.46 repeating, but it rounds to 4.5. Okay, I didn't actually have to do all that math. We could literally just observe it and say, okay, I know that if I take 6.7 divided by 1.5, we get B. So in the other direction, we could do all that math again, but we know we're just going to multiply by 1.5. So I have K is equal to some unknown at A over 8.2. We can see if we multiply both sides by 8.2, 8.2, we get A is equal to 8.2 multiplied by 1.5. We get 12.3. So overall, we have this, the dimensions of this larger four-sided object is going to be 12.3 meters and 12.3 meters. And for this one, we're going to end up with our 4.5 meters.